Happy morning, dear friends. Here's yours, Dr. Rajanta. Welcome to Demystify with Ajay. Dear friends, here we are going to have our second part. Welcome to the second part of our comprehensive machine learning series. And today we are going to discuss from model selection to model evaluation. Yes, we are in the session, we are going to continue our journey through this machine learning pipeline and focusing on selecting the right models, training them and evaluating their performance, and you will gain insight into various algorithms, model training techniques and importance of rigorous evaluation. So stay tuned to discover how to optimize your model and ensure they are ready for real world applications. Let me just start. Of course, dear friends, this exact data and task, of course, we have already discussed, and so far we looked out two jars out of 6. We have come across data and task, and we are going on to the third chart, that is the model. So we had some data, and we said that data contains two parts. One is X and the another is Y. And where here X is the input and Y is the output. So here you have images and you have the output as of one of the several classes, and that here I have considered is 5 classes. So here you have images that the output where you could belong to in this cases. Okay, so when on just going towards the data, kindly just look something to this form. You have the collection of numbers, and each of these represents the values of pixels. And dear friends, so this is the exact first 30 cross 30 images, and of course when you just have it, so totally 900 pixels you would just have, and it is a pixel value, and then you have the label association. Okay, so label association with these images. So now you all understand that there is some true relationship between that is already exists, which is existed between the input X and to the output. Okay, so this image is classified as like a dot because we actually because these are some functions which takes the image and gives them the output. Right. So the problem is that in most cases you do not know what is the exact f of x, that is what is the function. If you take any application when you want to use machine learning, it would be typically be the case that you don't know what is this function or what is the function is. Okay, so if you already know the function, then there is nothing to learn, right? So if you know the function as like say as sine of x or cos of x or what you already done, of course there is nothing there to learn or nothing there to make the machine to learn or to train it. So of course it would be the same as like y is equal to f of x. So what we typically do in machine learning is that we come up to look up all the logs of this data, and we have a lot of such data that is to train it. Okay, so in that training, where we have this X and to that Y, and on in this cases we realize that there is some relationship between this f of X and to that, the relationship between X and to that of Y. Now what we do is we say that we do not know what is the true relationship, but of course, we know what is the approximation of this relationship between this y and x. So we come up with some function which we believe best approximation the relationship between this y and x, or x and y. So that is what a human does for machine learning, or would just do us for a designing purpose. Okay, so come up with such function and say that I think this function would be best to describe this relation x and to that of y. And now let us understand this in much more detail. See how here we are having an example, right? And I just take simple one-dimensional data which you have a certain x and y. Okay, so yes, when we just have towards this approximation, we are just going to have this, yeah, of course, this is the exact image which is associated, and we are just going to have this as like a one-dimensional array, and let me just plot it into an machine learning model. Okay, so how we are just going to have it is, yeah, this is what a simple one-dimensional data, and you have a certain x on this horizontal axis and y on towards this vertical, okay, and each point corresponding to this or each and every data that is corresponding to this or x comma y. So I have the each point here has both this x and y coordinates. So now actually I have designed this or I have plotted these points to actually first construct to this function. And let me just make it what would be. So here we are still, I'm just specifying, we are going to construct an approximation, not a true relation. Okay, so yes, dear friends, so let me just construct something as like, if you just want to say x as like into a cos of x square or plus sine square, yeah, you can just make it. So something of that sort or some complicated function come with a combination of cos and sine and some coefficient or there. So here what would be your output? So here it is what that x and y, and we just going to make a plot accordingly here. Okay, now let me just define something as a mathematical function. Okay, so there is exactly here we are having a true relationship between y and x, but you see, it is not this exact function, that is y hat. It is not a true function. We are just going to create an approximation of the function. Okay, just see that I am not told what function is. Now, from this data, your job is to come up with a function with a best example relationship between x and y. Okay, and just as in this case, here we are also a function could be very complex also. Okay, and not will be explicit. So let me see how this has been processed. Okay, so I want to do first, we will start with a very simple function. We will say that I believe this relationship between this x and y would be a linear relationship. In other words, you can just say y is equal to mx plus c. Here it is y hat. Okay, y hat is equal to mx plus c. And now from all these data that is given to you, you will try to learn these parameter from this m and to that of c, and now know that learning m and c is very simple problem. Even if you have just 2 data points, you can estimate this parameter m and c. Okay, but the problem here, the catch here is that no matter how you adjust this parameter m and c, yeah, it would be in a straight line. You can see that when I am adjusting in this each and everything, even if I just have this is the m and c, or this is m and c, or this is m and c, or whatever the thing. Okay, so even if, no matter what I do, I can't come up with a line which passes through all these points. And that is exactly what I would mean by discovering a function which captures the relationship between y and x. Okay, in other words, if I learn m and c, if I try all possible values of m and c, okay, from many of these points, here when I plug in the value of x, the answer in the model is going to give me which is y hat, is going to be different from this two output. Yes, which I have here in the form of that is right points, that is the true point. So let us take point to find, no matter how learns these values, I'm not going to get this corresponding y value output. So then I realize maybe this is not a linear function. So I should try more complex function. Maybe you can just go with linear, here it is not a linear, so non-linear, or even you can just go for a polynomial. Now let I try maybe a polynomial of degree 2. Okay, degree 2 polynomial, and now my job is to try to learn these parameter a, b and c. I try to write every time you see we would have a different curves like this or like this or like this. So there also different curves, okay. And when I tried at different values of ABC, it would be easy to convince yourself that no matter what value of ABC you try, you will not be able to get a situation which for any given x, here the output of the function, which is green in color, okay. So here it is what in green in color, okay, would be the same as red point. That is not going to be happen. Okay, so what it is? So that is also not a complex enough to actually capture the relationship between A, there's B, C and D. To make it, of course, here when we just combine towards this X input towards this Y output. And now let us understand what the machine is actually doing here. What the machine is doing is that it trying to very efficiently find the best value of ABC and D also. So that across all these points, my error is as low as possible. That is, I should be close to this prediction as possible. It is just an impossible task in this case because my function is not complex enough to capture the true relationship that is between X and Y. Okay, the job of machine is to come up with very efficient algorithm to capture this estimation of these parameters. So once again I have failed. So what I will try to do this is I try to come up with even lower complex function. Okay, so which would be as like degree 3 polynomial. Once again the same story repeats. I try to adjust the value of A, B, C, D such that my green value is close to there. And see the plots, but no matter how I try, I am not able to really achieve that. And keep doing this which increasingly complex function until I reach 25th degree polynomial which is coming very close, not exactly overlapping with the red point, but still coming very close to the function that captures the relationship between Y and X. I could still alive with this function. Most of the points are close, but I could have probably tried even better function. So this function that you try these, or that is what it is known as the model. So because this explains or tries to model the relationship between the Y and X, this is where the ML engineering comes with. Or this is what an ML engineering does. Okay, tries come up with a different function which could approximate these exact relationship. So they are going to assume that the output is related to that input by this function, and then the job of machine would be estimate these parameters. What are all this? The A, B, C, D, which would be millions of such parameters. In the case of these functions, and the machine is going to help us find these parameters A, B, C. Actually here I am just showing only 4, and here it would be having an n number of parameters. Okay, finding these parameters from the data so that our green curve, okay, is very close to that red curve. That is the red point curve. And the other important point that you need to realize is that is very simple example. I will actually able to plot X and Y because of this example without actually trying the mx plus c. Okay, it is very easy for me to see that this is not a linear function. I cannot draw any line passing through this. But in most real cases, you will not have a liberty of visualizing the data because the data would be very high dimensional. It would be like 1000 futures or 10,000 futures. Even if you take an image classification problem where you are dealing with a high definition image of say 1000 into 1000 pixels, you still dealing with a total number of 1 million dimension data. So right. So X is very high dimension. So you can't visualize it and try to figure out what is the function is that. Only choice is to try some known parameter function, and is also means that the parameter are built from the given data. Okay, right. So if I were to estimate the parameter of this line Y, which is equal to mx plus c. Yeah, it would have been very easy for me. I could have found the line which is very close to the true function. But in this case, although you know, or you are having this function, which is this red point curves, and you come to the value of y for different values of x. And you find that the function that he has suggested is actually represented by this red point curves that you see, and you can see that it is actually very close to this sine function. Okay. Now what you do it is that is actually able to know what are all the exact models. Okay. So here you have created one model. You are suggesting one particular model. And with that model, I just want to know, yeah, whether this is the exact model or decided this one output. So you want to know whether this is the exact best model or not. But that it is not at an end. Why? Because see, actually, whenever you just specify one thing, kindly just observe, dear friends, whenever you are coming up with a model, you have to specify whether the model are going to talk about this one, or whether the model going to analyze it or predict, or what is the exact task it is of. Okay, so now so far we have seen these actually three jars, that is the data, task, and to that model. And in this, what is the next one? It is the fourth model. Okay, that is the fourth. We are going to talk about that. It is what it is it? Whether this exact model, do you have it is the best model or not? So how do we know? How do we know that? Yes, let me just, if you tell here, this is the exact saying that you could try different function and figure out which is one is it. Say, suppose this is the true relationship between the input and output. So here I am just drawing some points. Okay, so this is what something very close to sine wave, but along with some noises it is that. So whenever you plug in an x, you get a value of y which is very close to the sine function, but also there is some noise, so it is slightly around the sine function, and of course in practice you do not know this is the true function or not. So this data, I'm just going to make it to one of my friend and ask him, let me know what is this function is, and yes, let me just have, he brings us with a same, okay, we just tell us, yeah, what is this function it is, and I feel this is the function, and he is actually the same, using the same degree 25th polynomial, and he also gives you the coefficient of these points. And this assume that he knows everything just by looking at the data, he can do it. And now when you trying to plot the function which he is giving you, that means when you plug in different values of x on the horizontal axis, you find that his function, that is to this red curve. So here we are having a red color curve. Okay, it is so you come to that value of for different y values and of x, and you find that is the function which he is suggested is actually represented by this red curve, and that you see, that is it is very close to that of blue curve. That is the close to that of this sine curve. Now you do not able to decide by one output. So what you do? Yeah, you are going to ask another friend. Okay, he also looks at the data and he also gives you one function, and that function that his friend gives you is very close again to the sine function, and you see here it is in a green color curve. Okay, so I hope you are able to see this green curve, and you talk, then you just specify, okay, we are having two curves now. Okay. Not stopping here, one more friend that also gives you the function, and again the function is with a black curve which again seems to very close to this sine. Now what happened? Now the question is, yeah, you have tried three different functions, and these three functions are all 25th degree polynomial, right? But I am saying they are different because they are having different coefficient. Yes, 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 yes. So I have to try these three different functions. Now, whose function is better? Or which one of your friend has really given you the closest answer to the true value or true relationship between x and y? How would you find it? If you try to visualize or visually inspect, it is not very clear now. With all these curves are actually very close to each other, and they are also close to the sine wave. So I can't say for sure which of this is best. But what I could do is, instead of looking at the curves, I could look at some numbers. So where are these numbers, or what are these numbers that I want to look at? So this, as I know, is a true output for a given x. I know what is the y, okay, and I also know what is the answer that I get according to my friend's function. Dear friends, kindly just observe here. This is when I just want to know what is this exact function. Before that, I need to identify the loss between the exact true value and to that of approximation. First of all, this is friends 1 approximation, the friends 2, that is friends 3, okay. Here, when you just want to analyze this loss function, what would you just do? Usually you just make it, okay, so this is the exact true function, and subtracting this, what is the exact difference? That would be the number. And when on just calculating everything, and you just make it the summation, and you just get the whole loss of this function. But it is not the exact. Why? Because kindly just observe here. Here it is 0.24. The next one, it is minus 0.25. So here the difference is minus 0.01. And let me just go for the next one. That is also 0.08 minus 0.09. That is also minus 0.01. Okay. And here it is 0.12 minus 0.11. So here it is plus 0.01. In some other cases, if one more maybe 0.01. In such a case, if I just make a summation of these points, everything, it will just get cancelled. And here what would be the loss? Of course it is 0. And if it is a 0 loss, it would be equivalent to true function. So we are not doing that. So in such a case, yeah, overall towards this, what we are doing it, yeah, I just need exactly a quantitative evaluation of how this exact equation or the function, which model it is the best. Yeah, I'm just going to use an absolute difference, which we are going to use is the square difference. The square difference it just gives you an intuition. So suppose for a given x and true answer, what it is, if we are just having as like 0.2. And here I'm just specifying 0.1. If I just make this exact difference to be square, yes, dear friends, there you can add all these errors, and of course the loss you are expecting would be low. That is, it is not low, it would be just simplified. Okay, so that is what I'm just going to specify. So that is the one reason why you take the square error between the true value and to that of prediction value. So now this is, I computed it, will get me a number, and I look at this number for this L1 for the first friend's output. Okay, so yes, dear friend, so I knew So I take a look for this second friend, and I just call this as L2, and I will look at it for the third one and just call it as like L3. So these are the exact loss function of these approximation value. Okay, so this quantity I can actually compute, and I will compute it for the first friend for an example. So see here, if I just have this, I'm just going to square it, and again I'm just squaring this, and when on just summing it up, I just get the answer as like 1.38. Okay, so making this taking the square of all these difference and adding them up of all the n terms, and this will finally give me a number, and that's how the bad or good estimation of my friend was. If my friend had made a perfect estimation, actually this number would have been, this number should be, if I just made it exactly, that is 0.24 minus 0.25 and summation of 0.08 and 0.09, so on. If we just get it, of course the error would be 0. So just I computed this error for one of the friend, and yeah, we just, so our loss function is something allows me to see how good or bad the model is, and how good or bad my current parameter are. Now the other way of looking it, all of these friends and chosen the same function with this 25th degree polynomial, but the parameter estimation that they had all for all the coefficient of the polynomial, they were different. So if a machine is trying to automatically estimate these parameters, and it is trying to channel between these different values of these parameters, the loss function can help the machine understand which of these parameters is actually better. So that's the importance of a loss function. Across various choice of models, or even within one family of model, here the family was a degree 25th polynomial, how to decide which parameter are better than the other parameter. And the way you do this is plugging those values for every training point and see how off you are from the true value. That is how far. Okay. So now, so this is very important concept required for estimating the parameters of a model. And yeah, dear friends, we are going to do different types of loss function later. One is here, I have just described about this square error loss, which I have already given you an intuition about it. And we will talk about it more detail later. And on the other loss functions that we will take about is cross entropy loss, and the third loss function is the KL divergence loss functions. And these loss functions actually allow you to deal with a large number of models and a larger number of tasks and along different data sets, right? So these are very important, and we will do this in later ML functions and ML algorithms. Okay, now we have our fourth jar, which is loss. So which actually help us to find which model is better as compared to the other model. And these models actually allow us to approximate the relationship between y and x, which we observe in some data. That is right. So that is the connection between these elements. Okay. Now, so far we have written 4 jars of machine learning, and now we are in search of this fifth. So let's see what that is. So that is, yeah, right now what we have is some data. So that, what is the first jar? So everything that you see here is a data, and the data here corresponding to some movies, it has as like a budget of the movie and box office collections, okay, and the number of action scenes in the movie and so on. Based on these data, I have defined some tasks, okay, and yeah, this task is given this an input, and I want to able to predict this output. So whatever be this output, okay, so which is that IMDb rating. and the critics rating or the review ratings or whatever be, you can just specify. So this seems like, yeah, well formed task, and so I have this correspondent to first two jars rate. So this part is a data part which we just have it, and yeah, this is the first part, and here it is the y, that is the output part. So I have x and y pairs in this task. And I have defined you to perform with this also. That is the next thing I have done is I have an algorithm. Okay, I have designed or I proposed a model which says that I believe that my output y, which I am debating in this case, is related to that input. And here the input is here as like x1, x2 and x3 by the following functions here. I don't know what would be this true function. Okay. But I propose that this is what the relationship is right. Okay, and the same, if there was some friend of mine would of course who could take this function and actually give me the parameter of this function, right? Okay, so that means he could just say that A is 3.5 and B is 2.5 and here the C is 1.2. Okay, so which is equal towards this. And now what is the next? Of course, knows this towards this, we are just going to evaluate the loss function. Okay, so yes, here we have the loss function, using which I can exactly excuse me, I can exactly tell how good or bad this exact function, that is friend's approximation or its estimation of parameter x. Okay, right? So now the unfortunate part here is, so now just to quickly again break into this context. So far we have data, we have a task, and we just know what is the x comma y. Okay, and we have the model here and we have the loss function, right? Okay, so these are the four jars that we have. Unfortunately, we don't know what is the learns this parameter. So about here A, B, C, relying on our friend to be able to give us those parameter. But in practice, this is not going to happen. Not even can actually state at this data, just learn out the parameter. It is not going to happen. Okay, so what we could do is to think of this parameter estimation as a search problem. You have to search it, which parameter. Here it is not exactly like this. Okay, you have to search problem like so. Let's see what I mean is, but what I will do is I am just going to treat this as a search engine. Okay, and here how I look at it is, see all these parameter A, B, C will I will do it for a sake of convenience. Okay, I assume that these parameters or the values that is lies between minus 20 to 20. Of course, in practice, I could even do minus infinity to plus infinity. Okay, numbers. But for illustration, let me just assume that the parameter values lies between this minus 20 to plus 20, and they are would go about this. Okay, I will just fix the value of A, B, and C to minus 20 to plus 20 and search across all the values. Okay, so A, B values would be like this and search across all the values of C. Okay, right. So let me just plug in these three values of A, B and C into this loss function and see which gives me the best result. Then I will change the value of B again or repeat this particular, in other words, or in the entire space that is between this minus 20 to plus 20 for all the values of A, B, C. I will compute the loss values by plugging in these corresponding values of A, B, C into this F, that is F of X. Okay, that is right. So then substituting that here and computing the loss. That's what I can do. Secondly, basically do a root function. See, actually all these values of A, B, C, and I am sure to get some values for which this loss is minimized, right? So that's how I treat it as like a search problem. Let me just illustrate again. Okay, so see here, this is how I would do this. So here I have an, you can see a fixed value of A, B, C. For an example, I am drawing all these and for values of C, and I am just going to compute the loss. I am keeping a trap of this is A, B, where is this values of A, B and C. Okay, I am going to keep tracking of minimum so far, right? So different values of A, B, C that I have tried what it is the minimum so far, and I am just going to compute it for all possible values of A, B and C, which I just specified, that is minus 22 plus 20. Now let me just make a search. Okay, and each and every time whenever I just make a search, yes, I am just getting a value of loss. Kindly I just go before again. So kindly just to see here, when my A is 0, B is 10 and C is 10, I have my loss as 15. And again when I am just varying my ABC parameter values, here it is 10 and 10 and 0, and kindly just observe my loss is 7.82. And dear friends, I will get some values of A, B, C. For this loss was minimized, and I will just output those values, and those values happen to be equal to minus 22 plus 20. And here let me just have A is 20, B is 20 and C is minus 10. And for whatever the reason, though that the value is in this case, and that is the exact parameter, the configuration for which my loss is minimized. What that means? So here my loss is minimized. If I substitute the values equal to 20, A equal to 20, B equal to 20 and C is equal to minus 10 in this equation, then I feed in this value of X in one row at a time and the corresponding Y. So if I compute using this function, then the output of the function is going to be very close to the true output. And these are the values for which across all these data points, the true loss which I make is minimized. Okay, so that is what I just need. But this is very brute function for 2. That is, I just have only 3 parameters. I can just run it for a couple of hours. I can try values from that is not only 20 to 20. I can just make it minus 2002 plus 2000. Of A, B and C and give it in a step size of 0.1 cycles. That goes minus as like 2000.1 minus 2000.2. Then it just could be 99.9 minus 99.9. So on. Already we are up to 0, and then from there already up to 2000. That is from minus to 0 and again 0 to again 2000. I will try all this combination of A, B, C and arrive at some configuration for which the loss is minimized, and that's where my solution would be so. So I can get rid of these friends who has I really relying on to find the values. I can just use the computer to compute these values in a force and arrive at an output. But clearly, while for illustration, this looks good in practice, this is not going to work right, because you're not having just 3 parameters. You are in your real world data, instead of this 3 component of X, which is X1, X2, X3, you would have around thousands of values. And it could be of thousands of parameters to estimate. And then you can't run this kind of group of search across all these problems. The parameter is going to be a bit expensive. So what you need actually is an efficient way of computing of these parameters. That is the given data or the given model and the given a loss function. That's what you actually need to have. That way, this is what a learning algorithm is. Now, what mathematically speaking is, what do you want to do to find A, B, C, such that this loss is minimized And the moment I write it as this, right, actually now becomes the optimization problem. And I will show it on the next slide. I just wrote, and then I have some more thing to say that about this. See, I have converted it into a new neat optimization problem, which says that the finding A, B, C such that this quantity is minimized, and you would have actually done this before. See, where you look at these things, right? Minimum of x square plus 2x with respect to x. What would just means? In find me a value of x, or which is this function becomes minimum or takes a minimum value, right? And the simple case, when you have minima of x square, you know the answer is, and if you remember from your, of course previously you would have just come across this one, okay? So now what it is, plugging all these possible values of x from the minus infinity to plus infinity. That is, see, noting what x square is and then deciding who actually 0 is the value for. It is the minimum. You actually have a very neat way of computing this, which has its root in calculus. And once you do that, you can very effectively compute the value of x for which the function is minimized. Now catch here, that is, for instead of x, we have a function depends on a, b and c. You have to find the parameter a, b, c such that the value of the function is minimized, and this function is nothing but the loss function. Now we can formulate this in an optimization problem, and there are many optimization always that is always available. This can make efficient compute, this solution. Okay, so now that's where the cracks of machine are utilized, and let's try to take a minute here. See, actually, to understand, let's try to distinguish between the human does and what the machine does. In a machine learning, this portion of collecting the data was the human job, right? You have to actually just find some SQL query to get all the employee data from your company, or get all the sales data, customer data, and all you also have something duration of forms when people were entering this data. All collections was done by you. Okay, that definition of the task. What is of interest to you, or what is x and y? Okay, what are all the things? You can just have it, and from that x you are going to predict what is y. And of course you can also try predicting the IMDb rating, and not trying to predict the number of actions seen. Okay, so action seen, that is in minutes in the movies, right? So that's up to you. What is the task of interest to you, whether you want to do sentimental analysis or classified documents or sports or politics, etc. That's a task, na? That is the human. Now again, what is the human is doing is coming up with a set of function, which he believes that is best approximation, the relation between y and x. And I will have something more to see about this is, human also comes up with a loss function. What is the loss function that makes sense? And here again, there are several choices. And I said earlier, you could have a squared error, you could have a cross entropy, you could have a KL divergency, and a few others also. So now, based on these, or he or her experience, the human has to decide which is the best one. See, after all, this is done. That means once you have the data, task, model, and loss function. That is what the fourth jar, which we have just previously seen here. Okay, so this is the x and this is the y, this is the input, and here it is the task. Okay, so input data, this is the task, and you have the model and you have the loss function. When the machine comes, the job of the machine is to take all these and compute these parameters as efficiently as is, and that's where the success of machine learning lies. Because even a human is able to do remaining these things. is going to be almost impossible in most situations to be able to efficiently compute these parameters, and that's when a machine comes in. It can do a lot of computation quickly, okay? So by following some certain well-known algorithm and then arrays and the solution, and more often that not these algorithms are actually normally have calculus or some basic linear algebra, and that's why calculus, linear algebra form some foundations of machine learning. Okay, so that's the key part to understand here. What is the human do and what does the machine do, and where does this success form now? Because of this ability of this machine to efficiently be able to estimate these parameters given a loss function as a model, and the human has some more liberty. It not really actually have to worry too much about what function he or she selects, or he could just tell the machine, okay, I think there are these hundreds or say around 50 to 100 different functions. Why don't we just try all of them? All these functions have a different form. Okay, some of them are polynomial, some of them are deeply composite function. Okay, so you can say that try all these functions, all of them are different form. Some of them are polynomial, some of them are linear, some of them are composite. All of them are different number of parameters. And you just try all these functions and tell me the best function and best set of parameters, which gives me the minimum cost, right? So because the machine can do this quickly, the human can take some liberty and try out a lot of function, so that again tries out to what is the capability of a human and what is the capability of machine. The machine can do things fast. That's why the human can take some liberty. That is what I am just specifying again. Okay, so lot of functions with the machines that can quickly interact with the right. So this is the complete story in some sense of what happens in machine learning and what the role each of us play in that. So a lot of you would have to play the role of deciding what is the data is and what is the input, output is formed and a fixed set of loss function. There's not a lot of variety here. For most practical application, there are only 2 or 3 loss functions which can be used in the in each and everything as a step by step. And the function that you are going to use are again as a repeat. You can also have some that is the algorithm as like supervised or unsupervised, and those are all fixed and functions that you will learn. Yeah, we are just going to again come across with so many functions. Each and every algorithm we just discuss one by one and what are all the categories is. Yes, dear friends, I am coming to this at last to the topic of this model. Dear friends, the actual jar that we are looking at, which is learning algorithm in this session. Yeah, we are going to learn a few learning algorithms, that is as like gradient descent and its variance and plus here also. Okay, other algorithms like AdaGrad, RMS prop. These are all comes under yes, we are just going to take it towards deep learning also, till deep learning, and we are just continuing this machine learning series towards deep learning series also. Yeah, few learning algorithms also we are just going to discuss. And yes, so when on all these optimizer, okay, these are all some optimizer solver which can efficiently compute the parameters that gives the loss function, and some models descriptions also is there. Okay, apart from this, we also learn something known as like backpropagation, that is also comes under deep learning, which is used for training the neural network, and it uses a backbone of the algorithm, and also something known as backpropagation, which is used for training the data, the optimization algorithm or the learning algorithm that we are going to see it in a deep learning series. Okay, so everything, okay, I'm just not going to confuse you towards the machine learning and deep learning. Okay, let me just proceed the exact learning series. Okay, so with that we are ready with the 5th jar, so which is learned. And I hope to see the connection between all these jars, and there's one more jar to go. Okay, so far what we have done is, we have looked at the first, that is the 5 jar, that is machine learning, how they interact with the table, or so they are connected from the data, and from data define some tasks where that have a relationship as like X and Y, and then we have defined the model, and of course we think which is the best approximation, the relationship between X and Y. And also we have defined the loss function such that if we estimate some parameters of model, we can find out how wrong or how correct the data is, and using all of these, that means the model, the data and to that of loss function, we know that is we have some learning algorithm which can learn the parameter of the model so that the loss onto that of data. Now, the last part, once you have all done all of these, once you have learned the parameter of the model, now you are ready to deploy, and already just send it to the world, and it is in the world. So now one of the things that people will ask you is, how do I assign the score to you? See, some anything M&N model, okay, how do you evaluate it? Now suppose you are building an image classification or pair, which learns to classify between one of these 5 which we have just seen, that 5 classes. Okay, I will calculate it. Now the person will give you some data, okay, and I have a model pass this data to make to make us like this. So see here we are having the exact data, and I'm just passing it to this 5 classes. And I will calculate it right now. The person will give you some data. Okay, I have a model passed it. So to this data, and give me the output, whether it is towards the true label or not. When on pausing that, see, I look at the labels generated here by the model, and one simple thing when I can do is, I can just compute the accuracy of the model the way it is done. And it is the way it is done, it is for an instant. Okay, so I will check whether the output predicted by the model is the same as to that of true model. So it turns out these cards, that is, see here, here it is 1, okay, and these cases, and towards these cases, and here to these cases, yes. In these 3 cases, the output is not same as to that of true labels. So out of these 7, okay, the persons gave me, which I just correct, only 4 output are correct. And it's very similar to how you test the code. And you have certain test cases, and you say that your code is bug free or perfect, or if you all the test cases pass it. And if there are some errors, you can see if those many errors are there, or out of 100, so you could clear only 70 test cases in which the cases you have test cases that accuracy. Okay, so how you just make it in some case? Yes. So when on just evaluating the accuracy, kindly just observe. So number of correct prediction and total of number of prediction. And in this particular case, which would be 4 out of 7, that is the number of correct prediction that you have, which is the numerator, and the total number of prediction. So that it is a straightforward. Now this is very easy for anyone to understand that, okay, my accuracy of this model is 55%. That means if you use me or use this exact model for 100 times, I will be corrected for 55% of that model. Now this is one way of evaluating the model. And dear friends, in many practical situations, you might also be okay at looking at the top of 3 outputs. Looking at the top of 3 outputs of each and every cases. And so think it is say that you are getting 3 chances to that model that takes this image and give me 3 answers, and I am okay as long as one of these is okay. So this is all this top of 3 accuracy, or I generally make a top of K accuracy, anything. So if you are just one example, but actually it does not make sense, okay? So but say you have a distinguish between some thousands categories, okay, some 1000 categories right now. So if you can give me 3 answers and one of the 3 answers is correct out of the total thousands possible, yeah, if anyone will give me just 3 answers and one of those is correct, then I would probably be very happy. Yeah, in fact, this is what you will regularly experience, na? When you are doing as like a Google search, and you will typically happy if you within the top 3 you get the correct link, because there are so many answers out there for you querying, and there are so many documents on the way, so it is not really possible always to get the best one. But within the top 3 or top 5, yeah, if you get the answers, yeah, more efficiently. Okay, so more efficiently if you just get the answers more often, so they are not, which will be making happier. Yeah, that is what something you regularly experience. Okay, when you are using Google or any other search engine, the top 3 accuracy here would be the number of correct prediction in top 3 divided by the total number of predictions. And so this is it. Another way of evaluating what is the accuracy or the top. So see here, yeah, you should ask me here, that is you already had something like a loss function, which we are deciding, which we are using to decide how good or bad in this model. And so then why not just use loss function as a sport for the model? Why you look at this accuracy? So before I give you an answer, see, actually it should be clear that accuracy is more interpretable. So if I say 60%, it is very clear that out of 160 cases you are going to do properly well. If I take it as like a square, or the loss was just 0.4, it is really hard now for you to judge how good or bad model it is, right? Okay, so yeah, let me just come towards this point, dear friend. So here, and towards very importantly, I just want to say here, this is a last important thing to understand, that is the difference between this loss function and evaluation, or rather what you do at a training time and what you do at a testing time. So remember all of these that you are doing, or you are challenging the data, you are defining the task in term of X and Y, and you are you are having a different model and a learning algorithm, okay, and towards the loss function. All of this was happened on towards the training data. And when you are dealing with the training data, your job is just to estimate these parameters as accurately as possible. And so that your loss on this training data is in many things. But now once you are done with this, you will go along, of course, the report's performance of this training data, right? So this is like reading the trigonometry chapter, or now you have a by hearted all the formulas there. You have done it to the best of the variability. Now you cannot go and tell the world that I know trigonometry. You see, you have to pass this test. So you will either have to do very well on the exercise set at the end of the textbook. That is what. Okay, or you will have to load 2 to 3 variables, or 2 to 3 well on some unknown problems, and which your coach or towards mentor gives, so that this is the exact testing part. So evaluation is never on the training part, it is always towards the testing part. And here I just want to add up one more thing, dear friends. Actually, whenever you just take the part of this testing and training, so kindly just don't take 50 as a training and 50 as a testing. Don't take this as an option. Even just don't go towards 60-40. Okay, so kindly just make this, if it is the training data, kindly just go with a 70 or 75 or 80. So in such a case, yes, both the things, it would be an efficient way of observation. No? So in such a way, I am just specifying that. And that's very intuitive to understand. That is from the, which I just specified a trigonometry example, that you would always be evaluated on some unknown things which you are not seeing on the training data. So surely, yes, you have to be differentiated with training data and testing data separately. Both the things should not be the same. Okay, so this accuracy, when you just make it, which is your training data does not relay, means that you have learned or completely understood the search. So this accuracy or any other evaluation matrix will always be computed on this test data. So what is the next, dear? Of course, dear friends, so we have our last and final job. Yeah, which is we are going to evaluate. So now I hope you all understand how all of these things are happening. So combining towards this, I will do a summary of all this and give you on some insight onto a code and how to view all these problems. And yeah, you are going to look all at this in the lens of this 6 jar or this framework. And yeah, let me just see it by a code. And yeah, I'm just going to switch over towards the code. Yeah, kindly just observe, dear friends. Okay, yeah, dear friends, here we just go with the machine learning flow one by one. So yes, for the first thing, we are just going to provide the libraries. That is, we are just going to import the necessary libraries, and let me just load the data next. And once for all, we are in need of summarization. So summarizing the data, or you can just say analyze the data, or however we just going to see the next one. And some analysis, it is by mainly by onto the visualization. So we are just going to visualize it, use the visualizing library. And next, it is all about evaluate. Okay, and last but not least, if you need any particular prediction, you can just make use further. So this is what we are just going to do step by step. Okay, so let me just first of all go into the main functionality. That is, I just want to need an import necessary libraries, and let me just go with some import pandas as PD for, yes, of course, we are just going to use the data. So we want to import the data, so load the data by using this pandas. And if I'm not aware, let me just make use of this numpy also. And let me just have something for an example. Yes, we just need to have a view of it. So I just go with matplotlib and pyplot as PLT. See, actually all these are alias names. Okay, and now next we are in need of this sklearn. Okay, so this is mainly towards the exact data what we are in use, and mainly this is towards the processing of machine learning. So I'm just going to import this mainly towards the particular functionality. So learn dot, and I just want to make model selection. Okay, so model selection, and I just want to import few functionalities. So what not all the things I'm just going to specify is, first of all, cross validation. So kindly just be aware, if I just give the correct one only, it would be included. So cross validation, and straight K fold, I'm just going to use it for evaluation functionalities. and yes, train test split to split the training data and testing data. So this is what, and once after making the learn functionality, that is the process functionality, I just want to evaluate. So for that I am in need of metrics. So for that metrics, yes, of course, here we are going to use classification related data. So of course, I just need to include the evaluation metrics which are all related towards this classification functionality. So yes, dear friends, here I'm just going to make use of classification report, or you can make use of confusion matrix, or you can just give accuracy. Anything, of course, the F1 score, all the things comes under here. Okay, so you can just specifically go towards particular evaluation metrics, or you can just commonly provide this as like a classification report. So I just let you know each and everything, what are all the important metrics and all. Okay, now as we are in classification functionality, I just want to include some classification algorithm. Dear friends, here we have just started only the machine learning flow. Now, till now we didn't discuss any of the machine learning algorithm. But anyhow, I just want to include some one or two classification functionalities here. Okay, so for that, let I just include something. So this is the exact model which I'm just going to include. So sklearn. I just in need of some 2 to 3. Let I just go with some 2 to 3. Machine learning algorithms. Okay, so first I just go with a linear model, and in linear model the classification functionality, it is on let I go with the logistic regression, because that is logistic regression is a classification algorithm. And next I just want to have a comparison between any of the say. Okay, let I just go with the tree so that I can import the decision tree. Okay, so and of course in decision tree you can just go with classifier or regressor. As here it is a classifier model, I'm just using this. Okay, so this is what a simple thing which we are making use of it, and I just execute it. And yes, dear friends, one is towards data and towards models and model selections and evaluating the models. And what are all the models? Yeah, here we are going with the 2 models. Okay, now next it is loading the data, and of course for your information, dear friends, I am here with this iris data. Of course you are all known about this iris data. Okay, so this is a one well processed data. Okay, so this exact data, it is all about a flower variation, a species. Okay, so here we have 4 columns, that is sepal length, sepal width, petal length and petal width, and this is the exact target, that is the Y. Okay, so here we have 4 input of this, and with the target as species, specifying 3 different classification, that is as like Setosa, Veriscolor and Virginica. Okay, so that is the exact classification. So let me just go with that. Let me just load the data. So to just I am specifying it as like as I have already imported the PD, that is the pandas. I'm just going to have read CSV, because we are having the CSV file format. So I'm just going to have that. Okay, so here we go with CSV file. Okay, so yeah. So now I just want to summarize it. So to summarize it better, first of all, let me just have a view. And of course, you all know this is the data, is the exact variable where this data frame has been stored. Okay, so that is what the data frame to be handled here. And I just provide that as like a head. Of course, this would be providing me the top 5 records. Okay, so this records, kindly just observe. So here we just have the 4 columns, and the last one, it is the target. And if you want to know about its shape, that is number of records, yes, of course 150 records. And to be aware, yes, this exact iris data, it has 150 records, and with 50 each species. Okay, so we have 50 each species, so totally 3 species are we are having, and it is comprised with 150 records. Okay, now even though you can just have it in a way as like a data dot Okay, I'm just going with the group by, and here let I just provide this spaces, and you can just know its size. And yes, dear friends, so Setosa it is 50 records, Versicolor 50 records, and Virginica it is 50 records. So totally we are having 150 records. And towards dear friends, here the next one, it is all about a visualization. So we are just going to visualize it. And to visualize this, yes, mainly if you want to visualize it, yeah, you can just make it in a process of univariant, bivariant, and multivariant. Okay, so in such a case, yes, here if you are making use of this plot, I'm just going to make use of such a plot as with box plot. Let me just go with box plot. Okay, so this exact box plot, one second dear friends. So this exact box plot, just kindly just observe here, we are having this 4 species. Okay, sorry, 4 variables, that is the futures. Okay, sepal length, sepal width, and petal length and petal width. And of course this exact if you observe and if you analyze this box plot, yeah, even we can just discuss a lot about this. Kindly just observe, we have an outlier in the sepal width, and kindly just observe here, we are having this median here, and when we just see towards this median line, and kindly just observe this petal length, the exact median line, it is not in the center, so this exact data would not be a normalized data. So all such a things, yeah, we are just going to discuss one by one when we just take it into the futures and future particular functionalities. Okay, now we are just want to know only the flow. Okay, even you can just see about the data distribution. Of course you can opt the histogram. Okay, so here in this functionalities, kindly just see how the data has been distributed. So yes, of course it is not at all normalized data, and somewhat here in sepal length we are able to see something normalized related to, so seem to be na. So here of course we are having a median in center. Okay, and even also if you want to go for something as like multivariant, you can just go for correlation, or even you can just go for scattered valuation. And here I just want to add up one thing, dear friends. Actually this exact iris data is a well pre-processed data, so here there is no missing data or no any other duplication. So here future functionalities, it is not at all needed. But anyhow, if you need to go with that, yeah, of course there is a one particular segment here, when we just make it on summarization or visualization, yes, there is one particular part, it is all about future engineering and towards the transformation. Okay, so yeah, we are just going to discuss it in detail in the next modules. Okay, so here as this is just a flow, and we are just going to look what is the next one. It is all about evaluation. Okay, so here evaluation, I want to evaluate the input and to that output. So for that I just take it as like an array. Of course this would be very useful when I just imported this numpy. Okay, so here I am just going to have these values. Okay, so of course you all know aware that the first 4 is all about X data, and this species is the Y data. So if I just want to split this as like X data and Y data, so how I'm just going to separate it is as like, here I just need of X and Y, and making this data towards the values, I'm just going to have the array every rows from 0 to 4. So 0 to 4 is in the sense 0, 1, 2, 3. It would be the values of the futures for X input, and here that is every rows of 4th column. Okay, every rows of 4th column, that is what Y. Okay, now I just want to split the training data and testing data, and here we just go, dear friends, the X train data, the X test data. and Y train data and Y test data. Okay, so here we are just going to make use of this training test split method, and with that we are going to provide three main attributes. One is this X input and the Y output, and the next one, it is all about the size of the test data. So here, of course, I'm just going to input X, Y, and the next one, it is all about test size. And here I just want to add up one thing, dear friend, as I have already specified. Yeah, the best it is things to have is 70-30 or 80-20. Okay, sorry, 75 and 25 or 80 and 20. So these are all the things which usually we used to have it. Okay, so let I just give here as 0, 3. Okay, so 0.3 it is in the sense 30 as a testing size and 70 as our training. Okay, so let I execute this. So now it has been splitted. So the training and testing data has been splitted. Now what I want to do is, yeah, let me just evaluate the model. See, usually what a machine learning developer would just do, yeah, they would just choose one model, and with that model they would just go and evaluate or do some performance or a transformation and then make the performance evaluation, and once it is done, yeah, they would just deploy it and make a prediction towards the output. But here we are not going to do any of the future transformation or all of that, just to compare some two models, and we want to see what would be the performance analysis of these two algorithms alone. We are not going to dive into this particular transformation, just to see the flow. Okay, so let I just create this, as it is more than a model. Let I just give make it as like a list. Okay, so let I just append each and everything. Okay, so one is, okay, I just have to give one more parenthesis. One is logistic regression. So I just called the logistic regression method here. And second models, it is all about what I have just given. I just given us tree, I think so, for decision tree. Yes, yeah, it is decision tree. So let I include decision tree, and here it is decision tree, and of course it is a classifier. Okay, so this is the two models. Okay, once after evaluation, I'm just going to check for the results. Okay, for that also I just give a empty list. Okay, so here I just make an empty list, and with this empty list I'm just going to store the result. Okay, store the evaluation result of this. Okay, and next let me just include the names of it, because I just want to take it as like an data now. So let I just take it this names LR and DT. So for that also one empty. Okay, now this is the main thing, dear friends. For this names and models in this model, I just want to evaluate the cross validation score, and how many times of this splitting. See, actually here we want to know what is the exact score of each and every models. Okay, we want to build this exact ratio. See, when we just go towards this cross validation, actually the random seed which we just specify it is, here we want to split our data set into 10 parts. That is, train on 9 and test on 1 part. Okay, and repeat all the combination of train test split. And here I have just included this stratified. One second, I just go there. So for cross validation, let me just give something. If I just provided as I have specified 10 and 9 now, so that is what n split. If I just specified 10, so 9 is for training and 1 is for testing. And here this stratified, actually stratified means that each fold or split of data set will aim to have the same distribution of example by classes, okay, as exists in this whole training data. And this last one, as we have already used for this number of training and testing data, okay, to have the splitting. And yeah, let me just make use that combination here. For that, let I have this name and this model in models. Okay, so how many models? We have 2 models here. And yeah, this k fold, this is a variable for the exact cross validation functionalities. Okay, and stratified functionalities also I have to provide. So yes, stratified k fold. And here one and only thing which I am just going to give is n splits. And how many splits? Yeah, if you just provided 10, of course 10 for training in the sense 9 for training and 1 for testing. And if you just specified here it as a 5, so 4 for training and 1 for testing. Like that only it just happen. Okay, so collecting that cross validation score by using the cross validation function. Okay, and here to evaluate our this is what the cross validation techniques, okay, to evaluate our model. Okay, here each and every model I'm just going to give here, and kindly just observe, dear friend, for validating. So that is for training, we have to provide our training data, that is X-train data and Y-train data, and towards the result we want the testing data. So here I am just going to provide X-train data and Y-train data. And for cross validation, I am just going to make use of this straight K4. So that one I provide here. And for scoring, yes, of course, you can just use any type of scoring. As I have already specified, here it is a classification thing. You can just provide accuracy, or you can just provide classification or confusion, whatever the thing. Okay, so let I just go with accuracy, just an accuracy alone. Okay, what is the next? Of course, I just want to append all the things in the list which I have already specified. So 2 lists are there, one is results. Okay, so here I'm just going to append each and every scores. So let I just provide the scores, and here I just specify. And what is the next? I want to specify the names, and here append towards the name. That's it. Let me just see the output. For the output, I just want something as like a format. What is the format? The first string format to receive the name. Let be like this. And second, to know the accuracy, even you can just specify it in the float. Okay, and if you need the exact word as a percentage, yeah, that is also can be included. Okay, and this is name, and here this score in a mean value. Okay, now I execute. Of course, I think it's correct. One more. Am I missing? No, yeah. So let me just, okay, somewhere. Okay, so this is for this. Okay, so once again, I'm just missing with some values. So just a second, dear friends, I just check with my output. Yeah, here I have to give it. Okay, so actually I have just missed this one, so double quotes. Okay, so here I just go with. Okay, so let me just execute. So I think now it is right. Okay, I'm just messing with the percentage. Yes, it's correct. Okay, so let just observe here LR and DT. So for this logistic regression, we are just getting 96%, and for a decision tree, we are receiving 90%. So apart from this, yes, dear friends, this exact particular flow of data, okay, just providing us with this cross validation and straight fold with 10 splits, okay, we are receiving this exact accuracy. And making a comparative, yes, this among these two, yes, this logistic regression just provides us a good accuracy, which provides us 96%. So yes, this is the exact flow. But even though I just specified, dear friends, here we didn't dive into much more important concept as like futures and futures related future selections and transformation, just to see the flow of machine learning step by step we have discussed here. Yeah, later we are just going to discuss each and every algorithm one by one, from starting from the supervised, and next it is on towards the unsupervised and with an ensemble. Yeah, we are just going to continue this machine learning series. And hope thank you, dear friend, for watching this the second part of our machine learning series. We hope you found this deep dive into this model selections and training and evaluation informations are useful. And with the skills, yeah, you will well on your way to mastering this machine learning pipeline. We just seen only the flow. Okay. So if you enjoyed these videos, kindly please like and comment and subscribe. Stay tuned for more videos and advanced machine learning topics, and practical applications are all awaiting in our next video. Thank you, dear friends, and happy learning.